Alright guys, I'm gonna go over some problems with you and show you how I would work them. This document is located on the PowerPoint in the section Punnet Squares. I recommend that you watch the Punnet Square video I have posted or embedded within the PowerPoint prior to trying to work any of the problems. Alright, well let's get going. So as I said, this document is on the PowerPoint. Now the first thing I did is I cut out this document on the dotted lines, and what I ended up with is a foldable that I can glue into my journal. Once I cut it all out, so you're going to need to pause this and cut it out, I identified heterozygous and homozygous on the outside. I know that we've already discussed these words and they were on the PowerPoint, but I think it's really important that you guys know and understand that your vocabulary is very important during genetics because most of the problems are going to use your vocabulary. With there being so many vocabulary words, excuse me, I like to identify my vocabulary and their meaning as I'm working on problems, and I'll show you what I mean by that. Now, once you've created the foldable, we're just going to identify heterozygous and homozygous. So heterozygous is when alleles for traits are different, and they are shown with two different size letters. Again, the letters are irrelevant, which letters you use. What's important is that you're using a capital and a lowercase. So in this example, we used capital T and lowercase t for heterozygous. Remember, the beginning part of hetero means different, indicating two different sizes. I would also like to note that we have a vocabulary word, and it is hybrid. Hybrid is used interchangeably with the word heterozygous. So if you see the term hybrid, you know automatically that they are talking about a heterozygous organism. Homozygous. When alleles for a trait are the same and they're indicated with two letters of the same size. For instance, capital T, or lowercase t. And anytime I see a word that starts with homo, I highlight it or underline it because I know that that word means the same. And I'll give you an example as we're working problems. I would like you to notice the vocabulary word purebred. Anytime you see the vocabulary word purebred, they are talking about a homozygous organism. They use purebred and homozygous interchangeably. Alright, so we're going to go to the actual problem and get working. My apologies, I just woke up and I've never done this before. Okay, so it says some trolls have one eye, capital E, or capital E, lowercase e, while others have two, lowercase e. I'm going to stop there. I like to just identify some things within the word problem to help me remember my vocabulary and what my vocabulary means as I'm working through these problems. And so the first thing I'm going to identify is that a one-eyed troll is dominant. And although it didn't tell me the one-eyed troll is dominant, I know because of the letters or the genotypes that they used. Anytime I see a capital E or a capital letter, I am going to know that that has a dominant trait. And so I'm just going to, off to the side, write dominant. Now I also see that two lowercase e's or two i's or lowercase e's are recessive. Remember, anytime a recessive trait is expressed, it must mean that the genotype both has lowercase letters. Alright, moving on. So two heterozygous one-eyed trolls are crossed. So on the Punnet square, we are going to cross two heterozygous one-eyed trolls. It's important that we identify the word heterozygous. Anytime I see hetero, I am going to identify it and I'm going to write the word different. Nope, I don't know how to write F's today. That's supposed to indicate different, but I messed up on my F. All right. This is important because I now know or remember that the letters or within the genotype, so this is my genotype, the letters within the genotype must be two different sizes. That means uppercase and lowercase. So when I go to my Punnett square, I know that I must have an uppercase and a lowercase for each organism. Now, as you saw in the video, it doesn't matter whether you put a female or a male on the top or side, you're going to get the same probabilities within the squares. All right, so what is it actually asking us to do? What is the expected genotypical ratio? We're not going to do ratios, instead we're going to do percentages of a one-eyed to two-eyed offspring. And what is the expected phenotype ratio? And again, we're going to do percentages instead of ratios. All right, so we're going to go to our Punnett square, and as you saw in the video, all you're going to do is drop whatever's at the top and bring over whatever's in the side into the square, and they meet over. So this one would be capital E, capital E. I bring this E down and this E over. Moving to the next square, I have a lowercase e and I have a capital E. Now, one thing to remember is that any capital letters will always go first, okay? So I will have a capital E and a lowercase e. Moving to the bottom square, I'll bring down this capital E and over this lowercase e. And for the last square, I'll bring down this lowercase e and I'll bring this lowercase e over. So that is my filled in Punnett square. All right, back to the question. What is the expected genotypical ratio of one-eye to two-eye offspring? Well, going back up to our question, we know to have a one-eye offspring, you must have capital E or capital E lowercase e. And to have a two-eyed troll, you must have lowercase e. So we're just going to figure out percentages. So my possible genotypes, based on my Punnett square, is capital E, capital E lowercase e, and I guess I should have written like this, and then lowercase e. Now, let's go back to our Punnett square. So because we're working with 4 squares, this total Punnett square is worth 100%. All right, now we're working with 4 squares within the Punnett square. If we take 4 divided by 100, that equates to 25%. So each of these squares is 25%. This one's 25, 25, 25, 25 for a total of 100. All right, so looking at capital E, I have one box that has a capital E. That means it's a 25% chance that that is going to be the genotype expressed. Going to lowercase e, I have one box indicating 25%. And then we have uppercase e, lowercase e, and that's a 50% probability. Expected phenotypical ratio. So phenotype, it's important that we highlight the word phenotype. This is physical, okay? So what are we going to see on the outside physically? So that would be one-eyed troll or 2 eyes. All right, so it says one-eyed troll is dominant, so anything with a capital letter is going to have a 1 eye. So I'm going to go back to my Punnett square and I'm going to count the genotypes that start with a capital letter. We have 1, 2, 3. So 3 squares would be 75%. So there's a 75% probability that the one eye trait is going to be expressed within the organism. All right, two eyes, going back up. In order to have two eyes, you must have both recessive traits. And going back to our Punnet square, we have one for 25%. If you look at the phenotypical ratios, 75% plus 25% equate to your 100%. Okay, so I'm going to go a little faster on this one because it is very similar. So in unicorns, having a white horn, capital W, is dominant to having a brown horn, lowercase w. Two heterozygous unicorns are crossed. What is the probability that the offspring will have a white horn? All right, so unicorns. Yay, we all love unicorns. Okay. Having a white horn is dominant. That's important to know and understand. And having a brown horn, although they didn't tell us, we see the lowercase letter and we know it's recessive. Again, we're going to cross two heterozygous. I'm going to highlight the word hetero. I'm going to write that it is different. It's just my reminder that hetero means different. So again, I know that I have to have two different sized letters, a capital letter and a lowercase letter. I'm going to stick to the W's just because that's what they used. Capital W, lowercase w. I'm going to fill in my Punnett square. I bring my two capitals in the first square. I line up my lowercase and my uppercase into the next square. Uppercase, lowercase. Remember, we always start with the uppercase. And last two lowercases. All right, it says, what is the probability that the offspring will have a white horn? Well, going back up to our question, it identifies that a white horn is dominant, capital letter. So anytime I see a capital letter, I know that that is dominant and that is going to be the trait that is expressed. So I have 1, 2, 3. Remember, the Punnett square is worth 100%, and so 3 squares out of the 100% would be a 75%. So my answer for this is that I have a 75% chance of having a white horn. All right, next question. Excuse me. Get some of my coffee. Here's my pretty coffee cup that I got from Alaska. All right, this next one. In griffins, the allele for black feathers, capital B, is dominant over silver feathers, lowercase b, which are recessive. Two black griffins are crossed and have a silver offspring. Okay, so this is a different type of problem. They don't give us all of the information up front telling us what we're crossing. They give us information, and based on that information, we have to infer what organisms are crossed. I think I'm saying that wrong. Okay, it'll get a little clearer. All right, so the first thing that I'm going to do, sorry, I'm trying to figure out how to record. I'm recording with my left hand and writing with my right. Okay. In griffins, the allele for black feathers is capital B. So I know that this is dominant, and I'm going to go ahead and I'm going to highlight because it's dominant. And silver feathers, lowercase b, is recessive. It says two black griffins are crossed. This is important. Going up here, we know that black is a dominant trait. So we can infer that both of our adult parent or our parents have that dominant trait. Remember, the only time a dominant trait will be expressed is if that genotype is available. Okay. So I know that we have two capital B's, just right off the top, because two black griffins were crossed. All right. I also have a silver offspring. Now, what do we know about the recessive offspring. We know that the only way for that recessive trait to show is if there is no dominant trait being expressed on the genotype. So coming back up to these problems, the only time the recessive trait would show is with these lowercase letters. And same over here with the lowercase letters. And so we automatically know that our silver offspring has lowercase letters. Now, where to put it at on the Punnett square? So I can't put it in the first box because I already know that capital B are going to be expressed because that's dominant. And if I bring these down, that doesn't fit, right? So I don't know what's up here, so that's a possibility. But once I bring this large B over, it takes that box out of the running. Going down to the third box, if I drop my capital B, even though I don't know what's here, I automatically know that there is a capital B in this square, and so my silver offspring definitely can't go there. The last box, though, is an unknown. I am not sure what genotype is being expressed up here, and therefore I can put my lowercase letters there. So there's my silver offspring. Now I can work backwards and I can figure out what the adult offspring must have as their second allele. So I bring my lowercase b up, I bring my lowercase b to the side. And now I can fill in the Punnett square. All right, let's go back over to our question. What is the genotype of the parent? Okay, so I didn't even have to fill in my Punnett square, but it's always good too for the practice. And the phenotype, the genotype is capital B, lowercase b. And the phenotype, of course, of the parents is black griffins, they said. The phenotype for the offspring for this one is silver offspring. Okay? It's very important we learn our vocabulary. You should be making index cards with your vocabulary words. All right, let's work this last one here. A homozygous red dragon, capital R, is crossed with a heterozygous red dragon, capital R, lowercase r. All right, so I know that homo, I'm going to highlight the word homo, means the same. And that hetero means different. I just like to break down my problems. So it's saying a homozygous red dragon, capital R, is crossed with heterozygous red dragon. So it doesn't matter where we put this on the Punnett square. So we have a homozygous red dragon crossed with a heterozygous red dragon. So we can infer that red is the dominant trait, right? Red is the dominant trait. Okay, what are the possible genotypes of the offspring? All right, well, let's figure it out. We bring this capital letter down and this capital letter over. We do that again here, capital down, capital over. Capital down, lowercase over, and capital down, lowercase over. Well, looky here. Every single genotype has a capital letter. Capital letters remind us that that is dominant, or we know that capital letters are dominant. Anytime a dominant genotype is expressed or is shown, that's the trait that will be expressed. All right, so the questions are, what are the possible genotypes of the offspring? Well, our possible genotypes are capital R, or capital R, lowercase r. What are the possible phenotypes? So phenotypes, remember pheno, or PH, that's our physical traits. I like to write it here, physical. And they all have a capital letter, so they're all going to show that dominant trait. They're all going to be red dragons. All right, so I hope this was helpful. I know it was kind of long, 20 minutes, and hopefully I didn't go too slow for you. There are more problems to work on the hub. There is a SpongeBob SquarePants practice sheet. It is not homework. We practice some of the questions in class, and I will have the answers on the Harry Potter genetic PowerPoint. For homework, I assigned the Harry Potter genetics PowerPoint, and there is a document that goes with it. I really recommend you go over it to practice your vocabulary words and to practice some more problems for the test. All right, let me know if you guys need any help. Bye.